Imagine you're working on a large spreadsheet. You ask an AI agent to run an analysis, and a minute later, it hands you back a finished result. But how do you know if it's right? What did it actually do? Today's agents work like black boxes. You give them a goal, they return an artifact, and you're left to figure out if it's accurate and serves your needs. To understand the core challenges users face with these agents, we first conducted a formative study with 8 participants using a baseline spreadsheet agent. 2 main challenges emerged. First, users couldn't probe why the agent made specific choices because the underlying formulas and data dependencies were hidden behind computed values, making verification difficult. Second, users hesitated to make edits because they couldn't predict how changes would propagate. Informed by these findings, we defined 2 design goals. First, to make agent execution traceable. Second, to enable granular intervention and refinement. Based on these goals, we built a Microsoft Excel add-in, Pista, from the Spanish word for clue or track. To see how Pista works in practice, let's look at a task, preparing a tax return. In this workbook, we have 2 primary sheets, an income summary for 2025 and a deductions tab. The income summary aggregates 2 sources, a $78,000 salary and investment incomes, totaling $81,250. On the Deductions tab, the user has 2 sort of deductibles. Take the $14,600 standard deduction or itemize expenses like mortgage interest and property taxes. Let's start asking Pista to generate a 1040 tax form. Rather than executing the task in one pass, Pista decomposes the underlying agent's changes into a sequence of traceable, steerable steps. It bundles the operations into digestible units, providing an in-situ explanation of the agent's logic. As the agent populates the 1040 form, the user can ask clarification questions at any specific step. For instance, if a line item is unclear, the user can probe its meaning before the spreadsheet becomes too complex to digest. This also allows for immediate verification. Here, the user inspects the cell references to ensure the mapping is correct. By spoon-feeding information, Pista offers deeper insights. When the user notices a discrepancy in total income, they can ask for a justification. In this case, the explanation helps the user realize they've forgotten their student loan interest. Instead of starting over, the user issues a localized edit scoped to that specific step. Because this change impacts downstream calculations, Pista automatically branches the execution. It regenerates subsequent steps from this new state while preserving the original sequence. When facing complex formulas, users can query the logic to make sense of the math before committing. Users can freely switch between versions to compare outcomes. Here, the user can clearly see how adding the student loan interest increased their refund from $1,814 to $2,364. This differential view allows users to explore multiple scenarios within a single chain of computation and compare them effortlessly. Pista allows for manual corrections as the agent applies changes. For instance, here, while prompted for state taxes, the user might notice that the W-2 withholding amount was captured incorrectly. Instead of a full reset, they can manually adjust the value in box 17, ensuring that all subsequent steps use the corrected data. While Pista's core interaction currently centers on a branching view, we envision this as just the first step in how users might visualize an agent's reasoning. In our current implementation, the branching view allows users to treat the agent's execution as a flexible path. Nodes represent specific spreadsheet states, and edges represent atomic changes. If a user decides to diverge, for example by adding student loan interest mid-process, they can branch off the main path to explore that alternative while preserving the original sequence. However, we can enhance this by offering alternative views. For instance, a hierarchical view would allow users to collapse low-level operations into high-level objectives. Instead of a flat sequence, tasks such as taxable incomes and deductions are organized in a parent-child hierarchy, helping users navigate the agent's work at different levels of granularity. We could also surface a dependency graph. Rather than focusing on the order of operations, this view maps the flow of data. It reveals the underlying logic, showing how raw inputs such as W-2 and 1099-G forms are required to calculate taxable income before it ever reaches the final 1040 form. By presenting these views, users gain different perspectives on agent actions, with each view focusing the user's oversight on a specific dimension of the task. To evaluate Pista, we conducted a within-subjects usability study with 16 participants, comparing Pista to a baseline agent of equivalent capability. We found that Pista improved participants' understanding of agent actions by making them transparent. Users could steer the agent generation more easily and reported greater control and stronger feelings of co-authorship over the output. For more details, please check out our paper.